buoys out there. There are different systems out there of buoys. They can be moored buoys. Boy, that's a hard phrase to say. Moored buoys. Or they can be drifting buoys. And we actually have both of them out there. Let's look at some slides here real quick. Yeah, these are just different kinds of buoys. This one kind of illustrates the nature of the problem. We can't see very well on the projector, but these would be critters stick up here on top of the buoy. I think they're seals or otters or something. I can't quite tell. Okay. Buoys attract wildlife because it's a place to park themselves, right? Birds, crustaceans, sea mammals, they like buoys because it's a place to rest and it's a place to crack. Okay? You can see that the nature of the problem here, right? You don't have to worry about the weather station down at the valley does not have to worry about a large mammal cracking on the thermometer, right? And if for some reason one would, there's a meteorologist 40 feet away who can go clean it off, right? Whereas these buoys might be 1,000 miles away from the nearest land, right? Okay, problems. There are lots of drifting buoys out there. I don't know who puts these out there. There must be some agreement with merchants or some merchant ships or something. But anyway, this is not a very good scan. But at any given month, you can go to the National Climate Data Center's webpage and you can see maps that show where all the drifting buoys have been. And they just let them go, and they drift for a while, and sooner or later they sink or get hit by a ship or something like that. But you can see the track as to where they've been, and they take various kinds of observations of sea surface temperatures and things like that. And they usually have some kind of weather stations on them as well. And
Is that a 1 month?
Yeah, this is right, a month.
Map.
That would be my guess, yeah.
Okay.
Yeah. It might be 2 weeks, I can't have to remember. It's whatever the standard map, you can get it off the Climate Data Center's website. Actually, I think this came from Pacific Marine Environmental Lab, the same kind of thing. Anyway, there's a lot of them out there. I think that particular data was about 270 on the track. That's a lot of observations. Of course, keep in mind this is big, right? I mean, this is probably the difference from like Florida to California or something right here, right? I mean, there's not a lot of, there's a lot of them out there, but the oceans are big. We also have moored buoys out there. This is the Togatau array. That's the Tropical Ocean Global Atmosphere Tropical Ocean Array or something like that. I don't know, tropical array for oceans. I can't remember. And it's a system of about 100 buoys that are more substantial, like the ones that Patrick was sleeping on. The drifting buoys are kind of small, little expendable things. They're more substantial, and they are in a fixed array here monitoring El Nino. They are tied down. I think the next slide actually shows how they work. Yeah, they are. There's a buoy up here. It's got weather stations. It's got some kind of satellite communications to go up to the satellite, and it's got instruments that look down on the ocean to measure the water temperature. And it's got some instruments that measure the water near the surface, because right at the surface, the water is sometimes cooled by things like evaporation and so on. I'll talk about that in just a minute. And then there's a giant cable all the way to the bottom of the ocean, and there's usually some sensors along the way as well. And then at the bottom it is anchored. Actually anchored, by the way, according to Patrick anyway, the environmental science major who works on these things, by the axles of retired railroad cars. Because they're really, really heavy. And they're cheap. You can get them, once they, whatever, the government can buy them cheap. And so they tie the end of that on there and they throw the axle overboard. Anyway, which it kind of even looks like in the picture. Anyway, so that's an example of the kind of moored buoys that we have out there. And the main thing I want you to bring out here is that this is a relatively cheap thing to do, but it is also a maintenance nightmare. Patrick works on a ship that their job is they go out and they service these buoys and they just move from one to the next. What a great job. There's the environmental science majors in here. You guys can look forward to that job. Anyway, and they go from buoy to buoy and they fix buoys. And my guess is that it is a job that never gets done, right? I mean, there's just more damn buoys with more problems. Patrick says that they often find buoys that have been hit by ships. They find buoys that have been vandalized. They find buoys that have undergarments on them, where people sailing have come across them and thought it was funny to tie it up and, whatever. They're a maintenance nightmare. It's a scientific piece of equipment that's basically just let loose out there in the environment in the land of salt and bird crap, right? It is hard to keep these things running. Okay, well, if it helps then to have people there, how about ships? Ships would be a good way to observe sea surface temperatures. They're actually out there in the ocean and there's people there. They can clean off the thermometers, they can do whatever. Now, it isn't like the government just has this whole fleet of ships whose job it is to go out there and monitor the sea surface temperatures. That would be really great. The government, by the way, does own some research vessels. You've probably seen this on, History Channel, Discovery Channel, whatever, where they take, some ship that goes out there, they monitor whatever. Okay? They've got like 2 of those, and they only sail when there's actually like a funded government experiment going out there. Okay? It's not like we go out there and measure every day. Rather, they make contracts with merchant ships. Merchant ships are out there anyway, and, well, frankly, it's in their best interest to have weather observations, right? Because if everybody's out there taking observations, that leads to better forecasting. When you're out there in the middle of the sea, you want a good forecast. So merchants are perfectly willing to play along with this and take the observations. There's a number of problems, though, associated with this, not the least of which is that these merchants who take these observations are by no means professionals. By the way, if you go out and get the tropical charts off the map wall or go online to any of a number of different charts, you can see these surface charts are often populated with ships reports out in the middle of the ocean. They're taken by non-professionals who have no way of knowing that when that thermometer says that the water temperature is 47 degrees Celsius, something's got to be wrong, right? What is 47 Celsius? I don't know, 120 degrees Fahrenheit, something like that. Yeah, right? You think your average sailor happens to know that that's wrong? Right? No, they just send it in. Right? So there's a huge quality control problem here, right? These are not necessarily people who've been trained to know how to interpret the observations that they're taking. There are serious calibration issues. It is not like the government pays to put a thermometer that measures water temperature on these ships. Rather, these ships have thermometers already. How do they do it? Here's a ship. He's hauling Toyotas across the ocean. There you go. Those are currently Toyotas. Okay. Here's the ship. Big old steamer cruising across the ocean. When the steamer is running, your car has a big combustion engine in it. How does your car keep cool? Because it's moving pretty fast and air flows across the radiator. Okay? These ships are steaming across the ocean, burning tons of diesel fuel, and moving 4 miles an hour. Right? It isn't like there's a radiator that's going to keep this ship cool. Rather, they're water cooled. They have some kind of port on the side here, and water flows in through the engine, cools it down, and goes back out. And they monitor the water here, so they get the temperature. Okay. Pretty smart, right? They use the temperature of the water that comes into the ship, and that's what they're measuring. And that water is also keeping the ship cool, the engine's cool. It's smart. It's obviously, by the way, kind of just schematic here, right? There's actually much more details on how the individual kinds of ships manage it. But do you think that the ship is terribly concerned whether this water is 68 degrees Fahrenheit or 68.5 degrees Fahrenheit or 69 degrees Fahrenheit? Do you think keeping this thing in super tight calibration is really that important? Not to the ship. Is there a difference in the sensible heat flux and the latent heat flux between 68 and 69 degrees Fahrenheit? There's a huge difference. Meteorologists want these temperatures to at least 1/10 of a degree Fahrenheit, probably less than that. Okay? The ship doesn't care. So these observations have calibration issues. Okay? There are whole offices at the World Weather Building in Washington, D.C., Camp Springs, Silver Springs, wherever it is, that are, their job is figuring out how to calibrate these things. Right? The reports that are coming in from ship 553day2fall2008part4 seems to be running 0.7 degrees Fahrenheit above normal, so we need to adjust its observations before we assimilate it into our model. Now the EVS majors can make fun of the ATS majors because they can aspire to have that job, right? Okay. By the way, there's also a huge problem that the sea surface temperature differs depending on the weight of the cargo. Because when the ship goes back empty, the other direction, if it does, or at least lighter, here's the problem. Now let's measure the water at a different depth. Okay? Now there isn't a huge difference between the temperature of the water 1 foot and 10 feet down, but there is some. I mean, in general, it's pretty similar because of the mixing. Waves mix the water, and so it tends to stay about the same. But you do need to know whether the ship is loaded or empty. All right, this could be a serious problem. It's also a serious problem because these observations are limited to shipping lanes. This is just like a 2-week period or something like that where ship observations came from. I'm pretty happy with the Atlantic, but the Pacific could do a little better. The ships are not going to sail 1,000 miles out of their way just to go get some sea surface temperature observations in a rarely observed part of the ocean, right? They're going to sail on a straight line to wherever they're going. So certain shipping lanes, like from the canal to Tahiti or whichever island this is, They get lots of observations. Plenty of other places, they're not an observation for a couple hundred miles in any direction.